Hello there, PO ears. As an engineer, when you're going to design some sort of machine or apparatus to do whatever task it is, you want to know as much as you can about all the different materials that you'd have available and all the different types of machinery or apparatuses that you can use to manipulate and create to solve the problem that you're trying to solve. For instance, if you wanted to power something, we've used motors already, and if we wanted to power something that was a distance away, here I have a motor, and I want to make this guy run up here. Well, to connect this motor to this arm, in this case we used a series of sprockets and chains. We could have used gears, we could have used shafts, but all of those are very rigid and very linear. If I wanted to turn this 90 degrees, it gets a lot more complicated. But that's one way to transfer the power from here to here. Another way is to use fluid power, and that's what we're going to start talking about now. Fluid power comes in two major categories. The first are hydraulics, which is any kind of liquid that's under pressure, and the other is pneumatic, which is any kind of gas, normally air under pressure. Fluid power has a lot of advantages. Unlike those gears and sprockets and chains that we just looked at, fluid power is very flexible. It's simply connected by hoses, so I can move it all over the place. So if I want to apply a force here, you'll see that it moves over here, and vice versa. But now if I decide, but I really want this one to go 90 degrees this direction, if the hose doesn't pop off, all I got to do is turn the hose, and it still works exactly the same. It can travel a huge distance. For instance, about 80 yards away, there's a huge air compressor that supplies air lines to all these labs. So even though that's way over there, I can simply do this. Grab a flexible hose, blow all my beautiful hair all over the place, but I'm able to do that because fluid power has a lot of advantages as far as flexibility is concerned. Fluid power is also a force multiplier, just like gears can multiply the force. So I have a little apparatus built back here, and you see I have two syringes, and they represent pistons, cylinders. I have a scale, got one of our friendly old weights. When I weigh that, it is 6.12 newtons. Now what I'm going to do is I'm going to have a force sensor right here. It's locked into place. It's hopefully going to be forced up by this cylinder. I'm going to place my 6.12 newtons of force on this cylinder, and we're going to see what happens. So first of all, let me zero this thing. And I know you can't read that, but here's my 6.12 newtons of force. I'm going to put it over here, let it go down, and I'm up to 10.3 newtons of force. How did that happen? Has to do with the area in those cylinders. So it's a very easy way to multiply the force that we get. So it has lots of advantages, lots of applications, and it's something that you'd be able to use if you were designing some sort of machine in many, many different types of industries, businesses. It's clean. One source, like that air compressor that's 80 yards away, can run multiple different areas. It can run machines in all kinds of labs. It's very easy and accurate. Think of someone with a joystick operating one of those huge backhoes that you see along the road, or big equipment that's putting in a pipeline. They can simply move things just incrementally, very, very gently, even though it has a tremendous amount of power. So that's the intro to fluid power. We'll be talking about it a little bit more in the near future.